Measuring an OPUS observation with Trimble Access and a Trimble R-Series receiver. So what is OPUS? OPUS is the online positioning user service. You can access it with the web address here on the screen or simply Google OPUS. OPUS allows you to upload a GPS data file collected with a survey-grade GPS receiver and obtain an NSRS or National Spatial Reference System position via email. Basically, you take your GPS receiver outside, set it up on a survey marker, let it collect raw satellite data, then you download that data and upload it to OPUS, and they send you an email with survey grade coordinates for your survey marker. OPUS works in two formats: rapid static, which uses 15 minutes to 2 hours of data, and static, which requires 2 hours to 48 hours of data. So to use OPUS, you basically have to observe at least 15 minutes of data and no more than 48 hours worth of data. How accurate is it? Under normal conditions, most positions can be resolved to within a few centimeters. Now this requires good GPS field surveying practices, such as keeping your receiver out in the open and away from obstructions that can block the satellite view and cause multipath. The longer you measure, or the longer your session lasts, the better results you will get. A longer duration session provides OPUS a better opportunity to accurately fix ambiguities and mitigate multipath error. A second independent observation, which yields a similar solution, is an easy way to increase confidence in your results. OPUS will use the best cores and orbits available at the time you upload. While most cores are archived within 30 minutes past the hour, some aren't available to the next day. So a good rule of thumb is if you log data one day, wait until the next day to upload it to OPUS to get the best results. The contents of this video. First, we'll create an OPUS survey style in Trimble Access. Then we'll perform an OPUS observation in the field, download the raw GPS data, convert that GPS data to Rhinex, upload the Rhinex file to OPUS, and then view the OPUS results. Creating a survey style in Trimble Access to record OPUS static or rapid static points. From the main menu in Trimble Access, tap Settings. Tap Survey Styles. Tap New at the bottom of the page. Give the style a name. For this example, I'll use OPUS. The style type will be GNSS. Tap Accept. Tap Accept again. Tap Rover Options at the top of the list. For the survey type, use the drop-down arrow to change that to Fast Static. Set the logging device to receiver. The logging interval can remain 15 seconds, or you can set it to whatever you need for your job. OPUS uses 30-second logging intervals. 15 seconds gives you slightly more data than you need without creating huge files. Leave the elevation mask at 10, PDOT mask at 6, tap 1/4. Choose your antenna from the list. For this example, I'll choose an R8S internal. Measure 2 should be the bottom of antenna mount. Set your antenna height if you're using a fixed height pole or tripod. You can type in 2M for 2 meters. If you're using an adjustable tripod, just leave this blank. That way it'll force you to enter in the correct antenna height at the time of your observation. Tap 2/3. And for this particular antenna, we can leave it at GPS, GPS L2C, and GLONASS. Tap Accept at the bottom right corner. Then tap Base Options. Set the survey type to Fast Static. Logging device will remain receiver. Logging interval 15 seconds. Elevation mass 10 degrees. Set the antenna type to match your antenna, in this case R8S internal. Tap 1/3. Leave measured 2 to bottom of antenna mount. Put in 2M if you're using a fixed meter or a fixed height 2 meter pole or tripod. If you're using an adjustable tripod, again, leave that blank. You can leave the serial number blank. Tap 2/3, and you can leave L2C and GLONASS checked. Tap Accept at the bottom right, then tap Store. Your survey style has been created. You can tap Escape at the bottom left, and then tap the X at the top right to leave settings and return to the main menu in Trimble Access. Creating a job in Trimble Access for OPUS data collection. From the main menu in Trimble Access, tap General Survey, tap Job to create a job. Now with OPUS, it's recommended to create a job for each point you're going to measure. The reason being, the software Trimble Access is going to try to merge all your raw data into one file, which makes it easier to bring it into a software like TBC for post-processing, but OPUS wants one file per point. So as you're measuring your OPUS points, create a new job for each point that you're going to measure, and you'll have a lot less headaches down the line when you're trying to get your data to process by OPUS. So I'll tap on New Job, give the job a name. I'm just going to call it OPUS 1. Now, the coordinate system really doesn't matter because all we're doing is collecting raw data, and then OPUS is going to process it and put that raw satellite data in the coordinate system that we tell them to, most often US State Plane, or it could be UTM. For this example though, I'll go ahead and set up the coordinate system as State Plane because most people that are doing OPUS are either going to be working in State Plane or UTM. They are going to be working in some known system. So we'll go ahead and set that up. So tap on Coordinate System, then tap Select from Library. We'll choose US State Plane or United States State Plane 1983. Then choose your zone from the list. In this case, I'll use Georgia West 1002. Check the box for Use Geoid Model and select your geoid model from the list. Tap 1/2. We'll leave our coordinates set to grid and put in a rough project height for your area. This doesn't have to be perfect, just something that's close to an elevation in your area. 1,000 feet works well here. Then tap Store at the bottom right-hand corner. Make sure your units are set up correctly. If you need to change them, you can tap on the Units button and set them accordingly. I'll tap Accept again, and now you'll see at the top of the screen I have a job created called OPUS 1. Measuring an OPUS point using Trimble Access. First thing I want to do is make sure that I am connected to the receiver via Bluetooth in order to start the measurement. On the right hand side of the screen you can see that I do have satellites available, meaning I do have a Bluetooth connection, but I want to tap on Instrument, tap on GNSS Functions, and tap Bluetooth. If you're used to using your GPS receiver as a rover, you'll need to go ahead and switch it from the Bluetooth connection to a rover to a base. We're going to measure our OPUS points in base mode. So I'll tap under Connect to GNSS Rover and set that to none. Then for GNSS Base, I'll choose my receiver there. Now you'll just have to remember to switch this back when you go back to doing RTK or VRS or whatever you normally do with your rover. Then tap Accept. Now I want to switch from rover mode over to base mode in my GNSS function. So I'll tap the base mode icon. And the data collector will look to go ahead and connect up via Bluetooth to my base receiver, which is now the receiver I just set up. Then I can hit Escape down at the bottom. The reason we want to do this and measure our points in base mode is when we measure points with Trimble Access, and use that fast static survey style we created, if we use measure points, it's going to create a piece of kinematic data in there that OPUS doesn't like. But under base mode, there's no kinematic data that's created, and you won't have to worry about fixing that in the office later on. So once we've switched over to base mode and we're connected up to our receiver via Bluetooth, to go ahead and measure a point, we'll tap the Measure button. We'll choose our OPUS survey style we created, and we're going to choose Start Base Receiver. We'll enter a point name. I'll say this is point number 1. And 6.562, I am using a fixed height pole there. Bottom of antenna mount is the correct measurement. So I can just tap enter. The software is going to warn me that the point does not exist and that I need to provide coordinates at processing time. That's fine. We're measuring a new point, so we know the point doesn't exist. So just tap OK. And then all we have to do is hit the start button down at the bottom right-hand corner. Tap OK. And now the base is logging data. To verify that the receiver is logging data, on an R8S or an R8 GNSS, the battery light should blink once every 3 seconds. On an R10, the data logging light should stay illuminated. Once the proper time has elapsed for your observation, tap Measure, tap your OPUS survey style, and then tap End GNSS Base Survey. We're going to tap No to power down receiver. And that'll leave the receiver on and our data collector connected to it so that we can download the raw data to the data collector. So to do that, tap Instrument, then tap Receiver Files. The file name is always going to be the last 4 digits of the receiver serial number. Then the next 3 digits will be the Julian day, so today was the 82nd day of the year. And then the file number. 0 is the first file, 1 will be the second file, 2 will be the third file, and so forth. So tap the file that you wish to download, put a check next to it to the left, and click Import. Tap Start, and the file will be copied over from the receiver to the data collector. Once the file has been transferred, we'll click OK. There is a delete option down at the bottom. I'd recommend deleting out your files every now and then. Once the receiver fills up, it won't log anymore. Once you get your data back from OPUS and you're happy with it, it's a good idea to, the next time you're connected up to the receiver, to check the files that you don't need in there and click Delete. Once you've completed your field survey, you'll need to download your raw data to your PC and convert it to Rhinex. If you don't have the Trimble Convert to Rhinex program, open up a web browser and go to Duncan-Parnell.com. From our homepage, at the top of the screen, go to Training and Support and Success Center. On the Success Center page, click on the Surveying tab, and under the Quick Links, we'll have an option for Download Convert to Rhinex. Once the download page opens at the Trimble website, you'll need to download and install Convert to Rhinex, and you'll also need to download and install the Trimble configuration utility. Once both of those are installed, go ahead and take your TSC3 and connect it to your PC using the supplied USB cable. Once Windows Mobile Device Center opens, click Connect without setting up your device. Then go to File Management and click Browse the contents of your device. Double-click on the hard drive of the TSC3. Then go to the Trimble Data folder. Open the login folder that you were using in Trimble Access, and then open the folder that's associated with your OPUS jobs. There you'll find a T02 file. Right-click and copy that, and then store it in a folder on your computer. In this case, under my documents, I have an OPUS Files folder that I'll copy and paste that to. Do that for all the different OPUS files that you have. Once you have those downloaded, we'll go to Start, All Programs, and under Trimble, you'll find Convert to Rhinex. Open the Convert to Rhinex utility, go to File, Open, and then browse for the folder that you stored your OPUS files in. Select our TO2 file, click Open. You'll see it'll scan the file and tell you when it's complete. No changes need to be made here. Simply go to File and convert files. It'll convert the TO2 file over to a Rhinex file and store it in the same folder that the TO2 file was in. Go ahead and do that for as many files as you need to. You can select multiple files and convert them at once. Once that's done, close the Convert to Rhinex utility and then open a web browser. And the easiest thing to do is just do a Google search for OPUS and choose the Online Positioning User Service from the NGS website. Once there, go to Choose File and browse to the folder where you converted your OPUS files earlier and Convert to Rhinex. You're going to choose the .160 file. Again, this is a year thing, so if you had files that were done in 2015, they'll be .150. In 2017, they'll be .170. But you want the observation file, and it's going to have the year denoted with it. So choose that file and click Open. Then you're going to select your antenna. Now, Trimble antennas are all the way down at the bottom. We were using a Trimble R8S for this. But you'll see all the different Trimble antennas, R10, R6, different models of the R6, different models of the R8 are there. We're going to choose our Trimble R8S. And then we're going to put in the antenna height. And this is to the antenna reference point, which is the same thing as the bottom of the antenna mount in Trimble Access. We'll just type in 2.0 since we're using a 2-meter rod. And then put in your email address. Then choose whether you're uploading to rapid static or to static. This is based on your occupation time. 15 minutes to 2 hours will go to rapid static. 2 hours to 48 hours will go to static. All right, so once your file is uploaded, you can return to OPUS and upload other files you need to, or close your internet browser and wait for OPUS to email your file back to you. When you get your report back from OPUS, it's important to check the report for accuracy. With an OPUS Rapid Static report, absent any warning messages that might be on the report, the best estimate of coordinate accuracy is the standard deviations reported on the report by single baseline analysis. And those are going to be found here next to your latitude, longitude, ellipsoid height, and orthometric height. So the standard deviations we have here are 8 millimeters for the latitude, 23 millimeters for the longitude, 19 millimeters for the ellipsoid height, and 24 millimeters for the orthometric height. So that indicates we have a pretty solid solution here. Now, for your point details, you've got your orthometric height here reported in meters. And then you also have northern coordinates and eastern coordinates, both in UTM and state plane, also included on the report. So looking at a static report, a few differences there to look at. With a static report, to check the accuracy, your observations used should be above 90%, fixed ambiguity should be above 50%, and your overall RMS should be below 3 centimeters. Now, static reports peak-to-peak errors for each coordinate. These describe the error range or the disagreement between the 3 baselines that were used in processing. So here the peak-to-peak error is 9 millimeters in the latitude, 8 millimeters in the longitude, 2 millimeters in the ellipsoid height, and 18 millimeters in the orthometric height. So again, a good tight solution. You know, anything really less than 2 to 3 centimeters in the horizontal and 5 centimeters in the vertical is a good solution. So again, for our survey data, we have an orthometric elevation or a ground elevation in meters, and then we also have a northing and easting in both UTM coordinates and state plane coordinates.